So our second unit of concentration is molarity, and this is the one that's more commonly used in chemistry because we love moles, and it allows us to do stoichiometry. So for this one, it's going to be moles of the solute divided by liters of solution. And I made a little note up here at the top that molarity is a little weird because both the quantity, molarity itself, and the units are abbreviated with capital M. So when we're talking about the molarity of the solution, you may remember on bottles when we did labs, there was always that big capital M at the end. That's the unit for molarity. It's read as molar, kind of like your teeth. And that just stands for moles over liters. So with these, you're usually, and for all of them, going to be given the mass because that's how we measure how much of usually a solid solute we have. So we'll have to convert that to moles and then plug it into the equation. And you can solve the molarity equation for the molarity itself, the concentration, the moles, or the liters, which means you'll be given two of the numbers. So the first one, we're given grams of solute, which will convert to moles. We're given liters of solution, and we're going to find the molarity. So NaCl in this case is our solute. It doesn't say, which means that this is going to be dissolved in water. Anytime you don't see the solvent listed, it's going to be aqueous. So the first thing we need to do is convert grams to moles. And to do that, we use the molar mass. So while you're home, remember, save yourself a few minutes and just look up the molar mass if you don't want to add it up from the periodic table. So grams times the molar mass, which is 58.44 for NaCl. Okay, and then when you plug that into your calculator, you want to keep 3 sig figs. That's going to give you 1.54 moles of NaCl. That is our moles of solute. So that's going to go on the top of the equation. So molarity equals moles over liters, 1.54 moles over 3.5. And again, keep that 0 for the sig figs. That will be 3 sig figs for our answer, which calculator comes out as 0.44. Add that 0 at the end to get your third sig fig. And you can either write the units as moles over liters or that capital M I was talking about at the beginning, which is read as molar. They mean the same thing, so either one is fine. So this would be read as a 0.440 molar solution of NaCl. And just like with the percent by mass, you want to list the solute as part of the concentration. All right, so that's solving for molarity. We can also solve for volume, which we'll do in the second problem, or you can solve for moles. Okay, so again, we're given grams because that's how we would weigh it out in a lab. So the first thing we need to do is convert this, which is our solute, into moles. So we got 410 grams of NaOH. Converting that to moles, it's about 40, let's see, 39.9997. It's ugly. All right, 410 divided by about 40 gives you, I think it comes out as like 10.2 or 10.3. This is only 2 sig figs, so you want 2 sig figs in your answer. Remember when you end with 0 there, you got to put the decimal there to make that 0 count. So that's moles of NaOH. So that's our moles of solute. This one, we know the molarity, the 6 molar. So we're going to plug in the numbers we know. So that's going to be 6.0 molar equals 10 divided by, let's do L for liters. So we're solving for volume, we're solving for liters. So when you have an equation like this, where you don't know the denominator of a fraction, I mean, if you go through all the steps for the algebra, you get the same thing. These can switch places. So it's like you're multiplying by L on both sides. That'd be 6 times L. Divide by 6 on both sides. So then that would be L equals 10 divided by 6. And the units will cancel out. Should have written it there, though. So you're going to do 10 divided by 6, basically in the calculator. And that comes out as 1.7 liters. And we don't need to write anything else. That would be 1.7 liters of solution. All right, so that is molarity. You'll have to do gram to mole conversions. Sometimes if you're solving for moles, they might have you convert back to grams, but you can solve for any of these in the equation. All right, that's it.